Hi, so in this video, we're going to look at the locus of the points given by the magnitude of a complex number. So in example A, we're told that the magnitude of the complex number z is equal to 5. And we've been asked to state the Cartesian equation of a locus and to sketch this as a graph. So if we were to plot this complex number on an Argand diagram, we're told its magnitude is 5, so it could have a real part of positive 5. It could also have an imaginary part of 5i, or a real part of negative 5, or an imaginary part of negative 5i. At any one of these 4 points, the magnitude coming from the origin would be 5, but it could also be at this point, or at this point, or it could be at any point along the circumference of this circle. So this is the sketch of a locus. To write the Cartesian equation, well, if we think about the imaginary axis being the y-axis, and the real axis being the x-axis, well, then we know the equation of this circle. This would be x squared plus y squared is equal to 5 squared. We can work out this 5 squared, so the equation would be x squared plus y squared equals 25. So this would be the Cartesian equation of the magnitude of z equaling 5. But we could have worked this out a different way. If we say, let z equals x plus iy, so it's got a real part x and an imaginary part y, then the magnitude of z will be equal to the magnitude of x plus iy. And we know that the magnitude of z is given as 5. And we can Pythagorize this x plus iy, so we have the square root of x squared plus y squared, and this will equal 5. And then we can take the square of both sides, so x squared plus y squared is equal to 25. So there's 2 ways of finding the Cartesian equation. We can do it geometrically like we have on the Argand diagram, but we can also do it algebraically like we have by letting z equal x plus iy. Okay?